Stuart A. Kauffman, A World Beyond Physics, The Emergence and Evolution of Life. Embark on a captivating journey as we explore the book A World Beyond Physics, The Emergence and Evolution of Life by Stuart A. Kauffman. Delve into the mysteries of life's origin, evolution, and growth, transcending the realms of physics. Discover how life's complexity and diversity arose from simple beginnings, constraint closure, self-perpetuation, and adaptation under the influence of chance and natural selection. Examine the indispensable role of biology in understanding the organization of life and the unknown potential of what might lie in the cosmos.
Beyond Physics. Physics unravels the universe, but the origins and evolution of life are beyond its scope. While physics explains what is real, it cannot provide answers to fundamental questions on our existence, such as how we arrived and why we exist. The future of the biosphere is predictable yet unpredictable, and the study of physics reveals little about the life thriving in the known universe. While appreciation for the natural world's beauty can be attributed to physics, it is time to explore beyond physics to seek answers for one's deepest queries. The emergence of life. Biology sheds light on the emergence of life in the universe. The concept of constraint closure explains how the organization of a cell or organism can lead to energy containment and useful purposes like reproduction. The first organisms set in motion Darwin's natural selection cycles, created new ecosystems and paved the way for diverse life. Unlike physics, there are no laws that dictate the evolution of the biosphere. The universe remains largely unexplored, and only a fraction of complex molecules and life forms actualize. The concept of constraint closure provides insight into the emergence of life in the biosphere. Life, complexity, and physics. Life exists to build complexity, forestall entropy, and give meaning to the universe. The second law of thermodynamics labels entropy as everything tends towards disorder. Directed energy postpones entropy temporarily, but life defeats it, at least for a while, by borrowing energy and channeling it to perform ever more complex work, including reproduction. Hearts, noses, ears, and feet exist because they confer advantages to their possessors, and each organism exists because of others, all forming the biospheric whole. While the burgeoning diversity that is the biosphere for the past 3.7 billion years is based on physics, it flourishes beyond a realm physics can explain. The cells make rules that focus energy and make ever more connected constraints. When the system closes, it forms a cycle, and the cell reproduces itself, an organization of life. Emergence of life. Life may have emerged spontaneously from non-living materials like amino acids and liposomes that can divide and reproduce. The emergence of life is highly likely to have occurred by chance as lifeless molecules connect and reconnect to form polymers, which can eventually process food molecules and produce a primitive cell system. Laboratory experiments since the 1980s have demonstrated the plausibility of spontaneous autocatalytic life on Earth, mimicking the workings of cells. Over time, molecules reproduced, diversified, and generated a chemical stew that gradually increased in complexity and diversity until the first metabolism arrived about 3.5 billion years ago. As per the theory, given a sufficiently diverse soup of molecules, there is a chance that some will be of just the right shape to act as catalysts, resulting in a self-sustaining web of chemical reactions. Emergence of life. A hot spring in Australia about 3.7 billion years ago may have been the birthplace of life. Molecules lacking a metabolism floated around waiting for a chance collision with other molecules that might provide a protometabolism. Mathematical models show that if sufficient protometabolisms emerged in the same stew as the molecules, they might eventually collide and join, leading to the birth of life. Random polypeptides often folded and could catalyze reactions, which increased the probability of reproduction and evolution. This compelling idea is supported by a wealth of scientific evidence and theories. The Science of Protocells. The biosphere's complexity and the formation of protocells. Protocells are believed to have originated from molecules that encapsulated metabolisms within liposomes, creating a system capable of diffusing energy from the primordial soup. As the liposomes grew and divided, the protocells became diverse and complex, using the constraints of the liposome to direct energy for reproduction. The challenge posed by the second law of thermodynamics is how the biosphere builds complexity in a closed system where disorder, or entropy, can only increase. Today's primordial soups create random pairings and mixtures of polymers, proteins, RNA, and peptides that constantly swirl and may give rise to the formation of protocells. Emergence of life. The origins of life on Earth begin with protocells lacking genetic histories. These cells exhibit agency, coexist and depend on each other, and adapt to their environments through natural selection. The emergence of these cells introduced meaning to the universe, and as they evolved, they created opportunity and niches for other cells and species to thrive and diversify, leading to a rich biosphere. The process of natural selection and pre-adaptation drove the development of life on Earth, ultimately leading to the diversity and complexity we see today. Life, beyond laws and equations. Life, though rooted in physics, surges beyond it into unprecedented ways of making a living in the world. The book emphasizes on how the first protocell mutation created the biosphere we experience today, and how niches emerge exponentially as life grows and evolves, surpassing mathematical equations or any laws.
In conclusion, A World Beyond Physics unravels the enigmatic wonders of life, offering a unique perspective on the origins, evolution, and interconnectedness of life forms. As we uncover the beauties of the biodiverse biosphere, we learn that life transcends the constraints of physics and creates its own opportunities and niches, forging the path for more species and organisms to flourish. Unpredictable, immeasurable, and beyond the scope of physics, life triumphs in offering meaning and purpose to the universe, even in defiance of entropy. The book opens doors to a deeper understanding of life's intricacies and the endless possibilities that the cosmos may hold.